In today's video, here is a very nice problem of Greece Mathematics Olympiad edition 1995. So our goal, we are going to determine appropriate value of n which make this whole term as a perfect square. Okay, so this term is built by three parts. So all of them, they have 5 as a multiplier. The first one has a n as an exponent, the second one has a 5 as an exponent, the third one has a 4 as an exponent. Okay, so on the way to the solution, we are going to check n is a odd or even. Okay, so there is a nice way to check the parity. We check congruence. Okay, now let's go through this one now. So we have this following expression: 5 to the n plus 5 to the 5 minus 5 to the 4. We are saying this term is a perfect square, which means it's going to be written on this form, on the form of x squared, like this. Okay, I'm going to reduce this one to mod something. So which mod is convenient to help us to determine the parity of n? If I'm going to reduce this one to mod 5, I get everything 0, so n will be cancelled out. This one is not going to be helpful. It's not going to help us at all. If I'm going to use mod 4, it's gonna make this n cancelled out as well, because we'll have 5 equals 5 plus 5 equals 4 plus number 1. So 4 will be cancelled out. We'll have 1 to the n as an exponent, and it will be disappear, which means we cannot benefit. We need this n stays here. How to get that? How to make n stay here? We are going to apply the mod 6, because reducing this one to mod 6. We need to take some values of x to see where we have a perfect square mod 6. Let's take 0 square, which is 0 square mod 6. Let's check the next value. 1 square is a 1 square mod 6. Let's check the second one. 2 square, which is 4. 4 will have 4 mod 6. Let's check 3 square. Let's check 3 square, which is 9. 9, which is 3 more 6, which is 3 mod 6. Let's check next value. 4 square, which is 16. 16 will have 4 more 12. Let's check 5 square. 5 square is 25. 25 is 1 more 24, which is 1 mod 6. Let's check 6 square. 6 square is a 36. 36 is a remainder 0 mod 6. Okay, so all of these numbers are reminders. Okay, when you apply the division, you will have these numbers as reminders. Okay, so for the next one, 7 square. 7 square is a 49. 49 is 1 more 48. Okay, which is the remainder will be 1 mod 6, because we know 6 divides 48. So I'm going to check the second one. 8 square. 8 square, which is 64. 64 is 4 number more 60. The remainder is 4. So I'm going to stop here, because we have kind of patterns. So we'll have 0, 1, 3, 4 are only perfect square mod 6. Now we are going to compare the remainder of this one and the remainder of this one. If you find any remainder in this set, 0, 1, 3 or 4, which means we have a solution for that equation. Okay, n is an even. If n is an even, we will have 5 to the n plus 5 to the 5 minus 5 to the 4 equals. So I'm going to reduce this one to mod 6. So I'm going to rewrite this expression as 5 to the n, which is the same as 6 minus 1 to the n. 5 to the 5, we will have 6 minus 1 to the 5. The last one, you will have 6 minus 1 to the 4, like this. If I'm going to reduce this one to mod 6, this 6 becomes 0, because 6 divides 6. So I will be left with minus 1 to the n 6 becomes 0. I get minus 1 to the 5, which is minus 1. This one 6 minus 1, which is 0. Minus 1 to the 4, which is 1. With this minus 1 becomes minus 1. So we said n is an even, which means this minus 1 turns into number 1. Okay, this one turns into minus 1. This one turns into 1. With this minus 1 becomes minus 1. So by cancelling out this one, I will be left with minus 1. Minus 1 mod 6. But minus 1 here is not available in this set, which means n is not even. N is an odd. N is an odd. If you want to check it here, we can check it. If you want to check when we have n is an odd, you can check it also here. When we have n is an odd, this one it turns minus 1. This one turns minus 1. This one turns minus 1 because we have minus sign here. Which means you have minus 3 mod 6. Minus 3 by adding 6 on both sides, I will get 6 minus 3, which is 3 mod 6. We already have 3 here, which means we have the same remainder for this one and this one, which means n exactly is a odd. Since n is an odd, we'll have 5 to the n plus 5 to the 5 minus 5 to the 4. So I'm going to take 5 to the 4 as a common factor. I will have 5 to the n plus 5 to the 4 is multiplied by 5 minus 1 equals x squared. So this one is clearly number 4 here. So I will have 4 is multiplied by 5 to the 4. By moving over this term to the right, I will get here 5 to the n equals x squared minus 4 is multiplied by 5 to the 4. Okay, so I'm going to make this one on the form of the square. So we'll have x squared minus 2 is multiplied by 5 squared to the 2, like this. Okay, now I have a difference of two squares here. I'm simply going to factor out this one on the form of the products. So I will get 5 to the n as a power of 5, which equals x minus 5 squared, which is 25. 25 is multiplied by 2, which is 50. We'll get minus 50 here. Factor x plus 50. This one is clearly is a power of 5. Okay, which means the right hand side of this equation must be a power of 5. Okay, so I'm going to transfer this one into the equation system by putting 5 to the a equals x minus a minus 50. Then the second equation will get 5 to the b equals x plus 50. Now I'm going to determine x and a and b. We are keep in mind here b is strictly superior than a. Okay, because this term is bigger than this term, as we have all of these integers as a positive integers. So in order to find x, the first thing we are going to eliminate x from this system by putting this equation minus this equation. Okay, which means I get x eliminator. I get 50 minus 50, which is 100. 100 equals 5 to the b minus 5 to the a. Since a is smaller than b, I'm going to take 5a as a common multiplier. Get 5 to the a, factor 5 to the b minus a minus number 1, like this. Okay, I'm going to write this 100 on the form of 2 square is multiplied by 5 square, like this, because this one becomes 4 is multiplied by 25, which is 100. Okay, so I get 5 is an odd. I have 5 here. I get this term is an even, which means this term goes to the 2 square. This term goes to the 5 to square, because this one is an even, this one is an odd. Okay, so I'm simply going to determine, we'll have 5 to the a equals 5 square and 2 square equals 5 to the b minus a minus number 1. Okay, so I get here a equals 2. By replacing a with its value in this equation, I get here 2 square equals 5 to the b minus 2 minus 1. Okay, this one becomes 2 square, which is 4. By bringing this minus 1 to the left, I get 5, which is 1. I will have 5 to the b minus 2 equals 5, which means the exponent here equals number 1. Okay, which means I will get b minus 2 equals 1. In the other word, b equals 3. So I have a equals 2. It's very simple. I'm going to replace this value of a and b into this equation. I get here a equals 2, here b equals 3. So I'm taking these values here and putting them in this product to find n. So we'll have 5 to the n equals x minus 50, which is this one, which is 5 squared, is multiplied by 5 cubed, which is 5 to the 2 plus 3, which is 5 to the 5. So I get n equals 5 with x. 5 squared equals x minus 50, which means x equals 25 plus 50, which is 75. I get 75 here. So I have determined pair of the solution. So I have ended with this video. If you have any question or suggestion, just put it in the comment section below. Don't forget to support us with your like and subscribe. Thank you for watching. I will see you next video. Bye.